Hello, everybody. We'll wait another minute for the guys who are late. So just, yeah, like 30 seconds.
We should have some music playing, like in the elevator.
Like music on hold on the phone.
Yeah.
Yes. So
that's maybe another feature that we'd like to introduce to Zoom.
Yes, I would just at least send a message to everyone on the chat in the meantime, right? And so people don't feel lonely, the one who arrived on time. And
actually, I suggest to start right now.
Yeah, that's what
somebody's like,
what I was thinking
that's
about.
pity. They can watch recording, right?
Yeah, it's already 2 minutes, so I think we can start. So guys, hello everybody. Welcome to our second Data Storage MythBusters interactive webinar created by our team, so DIAWAY and LizardFS, as you can see here and here. And yeah, so thank you very much for joining us today. It's a great pleasure for us. So my name is Anton. I'm Business Development Manager in LizardFS. And together with my colleagues from LizardFS and DIAWAY teams, we would like to share some very valuable knowledge with you. And let's start with the agenda. So during the next 45 minutes, we will discuss scale-up storage solutions from both software and hardware angles, and of course, an economical angle too. So you will have a possibility to learn about the best modern practices on how to build a truly scalable storage. So also, please use our chat or Q&A button to ask your questions, because we will have a Q&A session in the end, and we will like to answer all questions you've got. So please feel free to use it. So at the beginning, a few words about today's organizers. So first team is DIAWAY. DIAWAY is data storage hardware integrator. They have done dozens of deployments all over the world, and they have delivered hundreds of petabytes data storage yet. And DIAWAY is also a technology partner of such technology giants like Acronis or Cloud Linux. And they are also a premium partner of Western Digital and, of course, of LizardFS team. That's why we're organizing this webinar together. And the next team is LizardFS. So LizardFS is a distributed file system inspired by GoogleFS. And so LizardFS is truly linearly scalable software-defined storage. And by the way, today is the day when we'll tell you what is the difference between this marketing scalability that storage vendors tell you that they are scalable and the true scalability of scale-out systems. And maybe a few another facts about LizardFS. Well, the largest cluster running on LizardFS now is an exabyte cold data storage. So that needed huge flexibility and scalability. And so that's why I'm here. And so you already know who am I. And maybe now, guys, let you introduce yourselves, please. So Frino, please, a few words about you.
Okay, thank you, Antonio. Hello, everyone. I am Neutrino, and I am very excited to talk to you today about different misconceptions regarding the scale up and scale out solutions, and cannot wait to also answer your questions on the end of the webinar.
Great, thank you very much. Dima, a few words about you, please.
Hi, everyone. My name is Dmitry. I'm one of two founders of DIAWAY, and I will be happy to discuss both technical and economical angles of scale up versus scale out storage topic.
Great, thank you. So guys, before we move on to busting our myths, so Neutrino, please, could you tell us a few words about today's topic and its relevance? I mean, why are we here? What are we trying to bring to our audience? What's the reason?
Mm-hmm. Yes, gladly, thank you. So I would like that everybody during this entire webinar has the same definition of this, what is scale up and what is scale out. So on the left side, you can see an example of scale-up solution when we will be thinking that this is something which cannot grow to the bigger quantity of controllers or servers, which is built from than two. Usually scale-up solutions are one controller only or server. So during the webinar, we'll be calling them controllers or servers. And on the other hand, on the scale out side, on the right side of the picture of the slide, you can see example of scale out when it's 3 or more. It could be hundreds of servers or controllers also. And for me, it's just important that each of us has exactly the same definition.
Okay, thank you. I think I can see already the difference, the basic difference between scale up and scale out. But also, do you know how the decision is typically made in companies? Dima, maybe you'd like to answer this question.
Yes, I can address actually. Henry Ford said that the customer always wants a faster horse. And I think that the same way of thinking is applicable to the storage systems as well. So in our case, the customer wants a bigger size storage box. And the reason why we created a webinar is to think out of a single box and unlock the financial and performance benefits of modern scale-out solutions. Because when you are upgrading the scale-up solution with a newer scale-up solution, it can be suboptimal, and there are plenty of different myths and misconceptions about scale-up. And this is how basically people are making their decisions. So let's proceed to myths.
Yep, let's do that. So the first myth for today says that 1 or 2 controllers performance ought to be enough for anybody. So guys, why is that not true? What is your opinion?
Yeah, so actually, I have heard Bill Gates saying something similar a long time ago, right? That 640 kilobytes is enough for everybody, or should be enough for everybody. So,
and I guess he was wrong, right?
Yeah, it seems so. I mean,
that's the spoiler.
At the time, it was looking like it's a lot, right? He just could not anticipate the need, right? And the growth and the development. So what I wanted to say about this first myth is that actually this is also looking like a truth. When you buy your scale-up solution, the box, right? And maybe 2 boxes, right, even. And on the beginning, you have a possibility to actually increase the performance together with the capacity. This is possible because, for instance, you can add new hard drives to the slots which are not being used in the box yet. And of course, each of these hard drives carry the additional performance which could be added, right? So I just wanted to say that it's not so simple, right? And there's basically some limitation, and it's not going to work like this,
So if at some point when you add the capacity with more and more drives, you will meet a kind of bottleneck and you cannot squeeze more IOPSs from your controllers anymore, does it mean that if we will look at the ratio between IOPS and TB, so something like IOPS per TB metric, that it will actually start dropping down at some point?
Exactly.
Right?
Yeah, exactly. That's exactly the problem. So the major difference between the scale up and scale out solution is that the IOPSs, the performance which you can get, it's per terabyte. At some point is going to reach this point which is on the graph, which is called bottleneck, and it will not grow anymore. And with the scale out solutions, it's not like that. With scale out solution, you increase the capacity and you will increase the other performance attributes along with it.
And what if let's say I'm a scale-up storage customer, and I'm just, I don't know, underestimated my capacity growth, and just an example, met bottleneck point after, let's say, 1 year of production. What will be the options for me?
Okay, so as I said before, on the beginning, you of course can start adding this hard drives, and then you meet this bottleneck point because you don't have any more the slots to add the new hard drives. And the only option you can have, if you want still to increase the performance along with capacity, is to buy probably the completely new hardware. Which after 1 year, there's a chance that there will be such new hardware, which is maybe faster, bigger box, you know, a bigger horse, as you said on the beginning. So if you want to stick with scale up solution, you want to increase capacity and performance, you need to buy a new thing. That's unfortunately the only answer I can for you. And yes.
Actually, I just realized that it's not the only case when you met the performance bottleneck when you just add more capacity. It can be, it can depend actually not only the capacity itself, but let's say the number of users, or I don't know, the number of services that you are running, the number of end users, or maybe a kind of the workload you are running right now. So, and
yes,
this actually leads us to the next myth.
Yeah. So, thank you guys very much for telling us the truth about this one. And the next myth says that scale-up storage solutions are everything for everything. So they cover every single use case that is available on the market. So why is that not true, guys? What is your opinion, please?
I think first of all, we need to talk about how these different use cases and features impress the customer. I know that sometimes the customer is actually buying the illusion of a lot of features. And speaking frankly, some of scale-up storage features are developed in order to take part in government tenders rather than for real production purposes. Also, we can see that typical feature-rich solution is not designed the way to allow you to use all the features you need simultaneously. So I would say that the reality behind this myth is that the customer either doesn't need all the features he bought, or can't use the features he needs in the requested workload mix ratio.
Yeah, actually, I wanted to just, sorry to interrupt you, Dima, but I just wanted to say that mixing different services and different kinds of workloads may lead to actually unexpected performance issues. We need to remember that we have when we buy the scale-up solution, we have a proprietary closed black boxes. The scale-up storage systems very often are using some kind of volumes virtualization. I mean, these volumes are virtualized inside of the box. We don't really have a control about every hard drive, every block device. It's really potentially also a big bottleneck for us, right? And if we are trying to mix the usage of one box for many different use cases, we can inviting disaster. Let me give you an example, actually, before I give you back voice, Dimitri. So many people in the world of the video editing, yes, I just met lately many people from the video editing post-production world. they are having the scale-up boxes over there, and they were using them quite happy for let's say 1 year, and then suddenly the system engineering team, the smart hands team, decided, you know what, in the specification of this box is written that we can also use it for virtualization, so why not to use it for some virtual machines which we will be using. And what they did, basically, they killed the performance for the video editing post-production team, and they could not use it. So what was the solution they applied, right, for this? They bought another scale-up box. But buying another scale-up box means that they could not conveniently share files fast between these two boxes. It was just not working. It was not reliable without maybe penalty for performance or the other things. So they start using this, you know, they start using this external 1 terabyte NVMe Thunderbolt hard drives, which they connect sometimes to one computer and then just carry it to another storage system to copy it between. And this, of course, invites disaster, right? So, yeah, that's it. I'm sorry for interrupting you. Please continue. Yes.
That's actually a very good example, and I think this myth is busted. And I think if we are like considering that scale up is storage is everything for everything, then we need to think more and deeply about the reliability aspect. Mm-hmm. And this leads us actually to the next myth.
Yes, exactly. So the next one says that to control a scale-up storage is truly reliable. So guys, what about this myth? And please also explain us what this guy is doing on the slide. What is it about?
Okay, so maybe I will just start from this, that nobody's immortal, and particularly hardware is not immortal. And
maybe only this guy on the picture only.
Yes, maybe
that's the point. Yeah,
that's true. Well, the point is that we should avoid the single point of failure as much as it is possible, and it's very important that when we think about this, we need to think on many different levels in case of the infrastructure for storing the data. And we need to remember one thing. If somebody is taking scale-up solution because thinks it's good enough for the person, and then or for any other reasons, you should remember this, that this, even if this is going to have two controllers, yeah, so two servers, this hardware is going to build from exactly the same components, from the same producer, the same firmware versions maybe even are going to be installed inside, the same type of hard drives, everything is going to be identical. So if something is going to go wrong because of the hardware issues, there is a probability it will go wrong on both of these controllers, you know? So I just want you to remember it, right?
Yes, I think there's even the probability that something will go wrong simultaneously or almost simultaneously. But I think it's not the question of whether two controllers would go down or not. It's the question, when will they go down? And I think that we need to focus on the, we don't need to focus on the specific reasons behind that, because it can be a mix of different reasons. Just to provide you an example, you can have a kind of maintenance with one of your two controllers in order to upgrade the software on one of them. And when you have some smart hands in your data center, and these smart hands, let's say, not smart enough, and they just turned off another controller, then immediately you will meet a very painful downtime, hopefully without data loss, but definitely it will be like very painful for you. And what we do for scale-out storage systems, the best practice, we are trying to offer as the default option the Erasure coding N+2 scheme. That actually implies that any two nodes of the whole cluster can go down, and the cluster tolerates such kind of DR event.
Mm-hmm. Yes, you know what? Actually, you said something very interesting, because you said 2 nodes. You didn't say 2 hard drives, right? So that's important to also notice that in the modern storage solutions architecture and whatever you are going to use for your businesses, you should remember that nobody is now talking anymore that one or 2 hard drives can be broken. Usually we talk that 1 or 2 controllers or servers can disappear at the same time or more.
Yes, yes.
And you need to be ready for
the right way of thinking. Yes, the right way of thinking here is like nothing is immortal.
Exactly.
Including controllers, hard drives, everything. So basically every component, including networking piece, can go down, and your storage system should tolerate it.
I have confession to do. You know, Dima, I need to tell it to everyone. So I was hired once by the company called ResearchGate, and actually I did for them the data loss, you know, the very serious data loss on the production for the software engineering team. And it was during my first 10 days in the company. They didn't fire me for that, because on the end, everything was because of the really bad communication about this, what I need to do. I just wanted to say that the human factor of this, that something can go wrong, is real. It's there, it's happening, yes?
More than real.
I know that you have policies, rules, and you don't touch the storage scale-up solutions in some companies, right? This is like one policy, don't touch it, it's working, right? But then you cannot, you cannot upgrade it, you cannot expand it, it's a lot of limitations, right? So I just wanted to tell you that this happened to me, you know, and in the very big company, yes, in big projects. And we needed to recover the loss. It took 2 months of working because this was some.
That is really painful.
Yes, yes.
So I think this myth is busted. Let's proceed to the next one.
Yep, let's do that. So the next one says that scale-up storage total cost of opportunity is always lower due to the lower initial cost, and that sounds good for me, guys, actually. But I guess you disagree with this one. So why do you?
Actually, that's my favorite topic about the money, and I can already see that there are some questions about the comparison scale up versus scale out, and I think we should consider 2 different cases here. So the first case is regarding fast-growing and large footprint, let's say multi-petabytes deployments. And for this specific case, I would say that the scale-out storage would be the best option. You will get the lowest TB cost than you could have with the scale-up. So for the large footprints, definitely it's better to stick with the scale-out systems. But speaking frankly, there are some niches like really low capacity deployments, such as, let's say, I don't know, 100 TB, 200 TB, when you can actually populate one server with hard drives. And for this specific case, the scale-up system probably would be more efficient, at least until your controllers have enough power to host more and more capacity. So basically, if you are not talking about fast-growing deployment, and we are talking only about like 100 or 200 TB, and it's not like expanding in times, then probably the scale-up option as a separate system would be cheaper than scale-out. But I think that we can touch one more topic here, since we can use scale-out software-defined storage in a different way. So Piotr, could you please provide some benefits of LizardFS based on your experience? What we can do with the smaller capacities?
Yes, I just wanted to say that it's actually true that our installations for scale out are bigger than 200 terabytes, yes, and there are petabytes, multi-petabytes very often. So basically the question is, so what we can do if we just need, I don't know, 100, less than 200 terabytes, right? Should we go and buy scale up and wait? No, the answer is you should not. I mean, you should not, because you may risk many things which right now are going to happen, especially the one that you will need to have a bigger capacity. Well, if your needs are maybe 10 terabytes, then maybe yes, okay? But if this is something close to hundreds of terabytes and it's not crossing 200, then I have two options for you, okay? So one option is use LizardFS or any other software-defined storage solution which is on the market available, and install it on your current existing servers in the data center you have or server room, okay? And buy extra SSD hard drive, put it to each of these servers and install the software and start using it, okay? And build the safe, reliable, scalable storage ready to be expanded with another controller and servers in the future. And the second option, this is something which we didn't announce yet in our company, but actually before the end of the winter, we are going to have a product which will allow you to have like one node LizardFS installation. And this will deliver still pretty big security level, and it will be ready for expansion. So actually you can start with one node even. You will not have obviously protection for disappearing of two different nodes with this, but the moment you add the second node on the third node, you will have this all benefits of the scale out systems. So please contact us about this if you are interested in details more about this, or wait for announcement before the end of the winter. As I said, we'll have it. Yes. So
actually, I like the idea. I like the idea that some nodes can go down, and I don't like the idea that we have only one node. So I think that if it's possible to combine the storage tier and insert the drives into existing service, it will be both the cheapest possible options, even cheaper than separate scale out or scale up system, and it will be the most efficient design if it's possible. So yes, I think that this myth about the TB cost is busted, like both for two cases, when we have an extremely large footprint and we have an extremely small one.
Mm-hmm. Yeah, exactly. Thank you guys very much. So as of today, about the misconceptions, all of them are busted at the moment. And now I think the most juicy part is that let's now move on to some key differences between scale up and scale out. And the topic that we've chosen is containers, so Kubernetes storage. What about this one, guys?
I would like to talk about the functions that we would need in case we are using scale-up system. And if we are talking about container storage, if we are talking about Kubernetes, we don't need actually block storage, or we don't need object storage here. So we don't need the universal solution. And of course, the customer doesn't want to pay for the features and functions that are not needed for this specific case. And my question here is, what would be the options that scale-up system can offer for Kubernetes? What will be the protocols?
Mm-hmm. Well, so actually on this slide, we kind of prepared the answer for this, right? So if somebody has some scale-up solution in the house and it's deciding to go Kubernetes and using the orchestration, and maybe is buying even additional hardware for that to handle this pods machines inside of the Kubernetes. Unfortunately, if you want to share files between these pods and you have more than one Kubernetes machine, of course, then you need to use some common accessible protocols by default, like Samba or NFS, right? And this is what many people is using, and they are basically wasting the possibilities of the scale-up systems by accessing the data in one point, right? Yes. So
I think all these protocols, both Samba and NFS, are binding on a single IP, so you cannot stretch the workload across two controllers you have. So it's a kind of bottleneck by design. So you cannot parallel the workload in this specific
in the same
case.
namespace you cannot.
But
exactly the problem. Mm-hmm.
Yeah. So if we will look at the LizardFS option, what will be the alternative here? So what will be the advantage of scale-out solution?
So the Kubernetes orchestration is by design scale-out solution, which is bringing a lot of things, and it also, of course, it allows you to use the local storage which exists on the machines, and maybe it's even scale-up connected to some of these nodes. But then you need to have 6 scale-ups connected if you have 6 servers, and this is not really efficient. And the LizardFS, on the other hand, it's also scale out, and like Kubernetes, and it allows just you to be installed on exactly the same machines. So exactly on the same servers which you bought, you install your storage software, you maybe add additional hard drives to these machines, or maybe they already have a lot of hard drives inside, and you build distributed file system, which any pod from any of these nodes can access, and they can share data together, can be migrated, they can disappear. You can even connect many data centers if you have done this way, right? So it's a very natural way of using LizardFS on your Kubernetes cluster.
So the idea is to have a unified scale step, so you can combine the LizardFS storage node and the Kubernetes worker node in a single server. And
yes,
this specific server will be a kind of building block for your infrastructure. You can scale your infrastructure with this specific server, so you don't care about the separate storage or
exactly.
So it's like much easier, and I think it's both efficient in terms of economics, because likely the cost of container would be lower if you have combined it in the same node, especially for the smaller footprints.
Yeah, actually, what you need to remember, the scale-out solutions are usually expensive per terabyte, because you always need to add to the price of the hard drives the price of controller of the server. And if you are smart, or if you have this possibility that you already are using the servers for something else, and you needed to buy them anyway, like for orchestration, for instance, in your data center, or you rented even the machines and you have them rented and you paid for them already, then actually the cost of your storage system is going to be only the cost of the hard drives, right? And that's
yes.
Much.
That's beautiful. Okay, I think we addressed this topic. Let's move forward.
Yeah, so the next topic we would like to cover is about these 3 technologies in network technologies used for both scale-up and scale-out data storage. So, Dima, what about this topic?
This topic is a kind of the sophisticated one, and probably we should make a separate webinar. about it. But if we will look make a helicopter view of these protocols, we have basically 3 different technologies right now that were either been extensively used in the past or now used. They are Fibre channel, Ethernet, and Infiniband.
Mm-hmm. Okay, so can you maybe tell us a little bit more about this? What is the difference, I know, in the terms of bandwidth and latency between these technologies? Just fast.
Okay, let's look at the bandwidth angle, and the leader here is Ethernet, definitely, because the Ethernet switches offer connectivity up to 400 gigabits right now. The Infiniband offers up to 200, and I think the last standard of Fibre channel offers 256 gigabits, but in practice, I see that it has no adoption in the market, and what I can see based on my experience, we can find like 8 gigabit per second ports or 16 gigabit per second ports. So Fibre channel here is a kind of outsider and legacy technology. And speaking about the latency, in earlier days, Fibre channel was a great option, since the latency is much lower than you can have through the Ethernet, just for example using such protocols as iSCSI, and it made much sense to use Fibre channel. But then there was RDMA invented for Infiniband. RDMA is a remote direct memory access, and then we have already 2 versions of RDMA over Converged Ethernet. As you can see here on the graph, it's marked as ROCE.
Mm-hmm.
So the difference between RDMA over Converged Ethernet and Infiniband is less than 10%. So Infiniband is slightly better, especially on the smaller message sizes, as you can see here. And then of course it's much better than like Ethernet without RDMA support. So that's basically it from the perspective of latency and bandwidth regarding these protocols.
Yeah, I just would like to make sure that everybody who is looking at the chart right now on the webinar, that everybody kind of understand that this ROCE, I know Rocky, ROCE is also Ethernet. Yes, so it's just the low latency solution over Ethernet, right? So please don't confuse that Ethernet is only the blue one. The ROCE also is using Ethernet. Yes. So by the way, Dima, can you actually tell us on the end, what is better? Because the difference is so small, Infiniband or Ethernet, because the latency, they are like almost the same on this chart when I look. What is better?
Yes, actually there are even some hybrid switches from Mellanox that support both Infiniband and Ethernet, and also there are network interface adapters as well. But if we are considering to build like a very scalable solution and universal, and if we want to simplify the maintenance of the network, I would stick with Ethernet, because it's like more universal. It has higher bandwidth and has like biggest market share, I would say. So I think that Ethernet is a leader here, but speaking about RDMA extensions, it's not strictly required, but in every case there are plenty of cases when you just don't need these extensions. I can provide you the example with if you are building a kind of backup as a service. If you are building a kind of backup as a service infrastructure, and you don't need to focus on the latency at all. The only thing you should focus is bandwidth. And actually you can use the infrastructure with like Ethernet without any RDMA support at all.
Yeah, so I think we've got the point already, guys. This makes a lot of sense for us. So I'd like to move to the next slide, as we don't have much time left. So maybe let's make some conclusions, right? So where is the land of milk and honey? Where is this best ideal scale-out storage solution? And
then we will answer the questions after this, right? So
yes, we will, of course. Sure, yeah.
Okay, I would like briefly address two items here, the first one and the last one. So the most the greatest advantage of scale-out storage systems is that you can have almost linear performance when you add more and more capacity. And actually, you can also refresh your hardware with adding more and more nodes. So you won't meet the situation then after 3 years, let's say, when you are buying the scale-up system, and after 3 years, you basically have 3 years old system. It's not the same. It's not the same with scale-out system, because you are adding more and more new nodes, and you have like a kind of mix of nodes of different age. You have some of them are 3 years, some of them 2 years, and some of them 1 year.
Because you buy as you go, you just buy as you go. When you need, you just extend, right? So this is why you.
Yes, and the greatest advantage here. Yes, exactly. So the greatest advantage here that you can refresh the hardware with adding more capacity, and it affects actually the economics a lot. So here I will move forward to another item about the lower TB cost. This kind of adding the capacity that scale-out system offers is more efficient in terms of economics, because if we will look at the HDD or SSD TB cost, it goes down year by year. So the capacity tends to be bigger and the TB cost tends to be lower. This means that if we can buy the capacity like not now, but in a year from now, probably we would get the better pricing for TBs, and the ability to add the capacity when you actually need it affects the economics a lot and lower the TB cost. Another great thing here is that you can actually combine SSD drives and HDD drives, like we mentioned for the Kubernetes feature. Then you would probably get the lowest TB cost at all, since it's very close to the price of TB cost of hard drive or SSD drive. So that's basically it. Piotr, could you please address the rest items here?
So I'll be more than happy to talk for a moment about this, what software-defined storage, which is usually being used on the scale-out solutions, is giving to the customer, to the user. So you have an influence, because it's not a black box solution. You have influenced this, what hard drive, which hard drive is going to be in what kind of group of the storage you want to. And and when I mean it, when I'm talking about this, I mean that you can do it on the level of the file, yes, because it's a file system. In our case, it's a file system, and you can choose any file you want or folder, directory, and you just can tell, I want that this particular file will be on this particular hard drives, on this particular servers distributed. You can influence it. You can define it in the software in a very easy way. You can use for this also labels. So when you can label different hard drives, like SSDs, HDDs, and that's a real, not virtualized hard drives, right? What I'm talking right now. Another benefits which you have, that you have a plenty levels of security you can choose. You can tell that some data are more important, and again, on the level of the folder, you can tell keep it in 3 replicas, or keep it with the equivalent of the erasure coding write 6 or write 14 if such write exists. But it exists in the software-defined storage, because you can decide how many parity nodes, how many read data nodes you want to have, how the data are going to be distributed and kept in your storage system per file or per folder. Or
by the way, the data schemes we mentioned, we are considering to make a separate webinar regarding the myths about data schemes.
Yes, exactly. So, okay, so maybe just on the end, I just say that we also have a topology, for instance, features, which every scale-out solution usually has, when you can just tell how close are the data to this particular service. So, for instance, if you have this Kubernetes orchestration, you can tell that these pods are being executed on this node, so they should read from the local hard drives instead of trying to read from the hard drives through the network, right? Of course, they will read still from the network hard drives if the local hard drives failed, or maybe they are too busy, the local ones, and it's faster to read using the one which are network attached, right? So the topology is just another.
I agree. Such flexibility brings many performance benefits here.
Yes, it is.
Yeah, guys.
Okay,
so thank you very much.
A bit of,
I mean, we're a bit out of time, but it's only 2 minutes, so I think that's the best time to move on to our Q&A session. But before that, I'd like to just show you the further topics that we are planning to organize the webinar on. So the first one is about data schemes. The second one is about proper storage sizing. And the third one is called Groundhog Day, like the movie with Bill Murray, about the never-ending data migration process to the newer storage system. So guys, please feel free to send a message on a chat or email us and tell us what topic sounds the most interesting for you. And by the way, today's topic was actually chosen by you. So I think
you can vote.
Works for us very good. Yeah, we can vote.
Everybody can vote now. And
Definitely.
if you are interested for the next webinar, for instance, in the number 3 topic, you just type 3 on the chat.
Yes.
And enter.
Yes. What is also maybe worth mentioning, if you'd like to ask some question, not here, but personally, just please send us an email or just feel free to call us. So, yeah. And yeah, so now the Q&A session, as I promised, and I already can see 2 questions. And so the first one is about Kubernetes, as I can see. So I didn't find any information about Kubernetes on your website. Is Kubernetes orchestration production ready, or are you planning to release it soon? So Trino, maybe a quick information about this one, some exclusive information.
Actually, the first time we are coming up with the fact that we are supporting Kubernetes is this webinar, and we didn't announce it yet. It is production ready. We have already some testing installations where we were performing this, and as we will announce it for sure before the end of the winter, but probably on the beginning of the next month. Yes.
Yeah, so Q1, let's say, yeah.
So yeah, so that's true that this could be new for the fans of LizardFS, that you didn't know that we actually are working along with the Kubernetes. Yes, we do. We have our own driver for this.
Yes, great. And yeah, and so what I'd like to just add that Kubernetes is going to be supported in our premium services set. So yeah, feel free to contact us to get more information about that. And actually, the next question is about prices. So, Dima, maybe can you just drop a link into the chat to our Sizer, to our services, so that people will be able.
Just a moment.
Yeah, yeah. There's a question about prices, whether they are available, and yes, our prices are available. And yeah, maybe that's another fact about scale up storages. So it's really hard to find prices about them.
Yes.
So yeah, we are open, guys, to that. So Dima, please just drop a link and feel free to
I just dropped a link with the Sizer and for the 1 petabyte footprint specifically, but you can choose the footprint you need.
I also would like to answer about the question which was asked, like, do you see a controller as a hardware product or also a software product, as we see in software-defined storage? So on the very beginning, we make a definition about this, what is scale up and scale out, and we said that the quantity of controllers or servers. So when we right now during this webinar, we're talking about the controller, we're talking that the controller is a hardware thing. But of course, in case when you are using the software-defined storage like LizardFS, it needs to be executed on the hardware. We just assume that each element, each chunk server in case of LizardFS is actually a controller, because everything which is taking actively part in the process of taking on itself the IOPSs or the bandwidth, we consider this a controller. Even if some small features maybe are being handled only by metadata servers, right? The most traffic and everything which is happening on the data communication de facto is being handled by each of our chunk servers even. And this is, for us, we also call it controller. So controller basically is the quantity of the hardware separates servers you have with installed software in case of software-defined software, and or with some kind of hardware if this is scale-out solution with the built-in hardware, right? I hope I answered your question.
Yeah.
Not,
yes.
I also would like to add a few cents here, since there are different things such as software-defined storage, which is very close to scale-out storage, but actually it doesn't imply that that software-defined storage is necessarily has scale-out design. I know there are some software-defined storages for scale-up systems. So in this specific case, you can take 2 commodity servers and install software-defined scale-up software-defined storage as well. So it really depends on the specific case. So in some cases, we should see a controller as a hardware product if this specific hardware is bundled with the software from the storage vendor. But sometimes we can see a controller also as a software product, since there are some legacy software-defined storage system that you can install on top of the commodity hardware as well.
Yeah, for instance, a very good example of scale-up software-defined storage will be ZFS, right? And everything which is built around it. For instance, I know about FreeNAS, which, for instance, is this kind of solution, which is a software, definitely, right? And, but they are scale-up. You cannot really connect 1,000 nodes between each other and have benefits of all of them, right? Yeah, but they are definitely software, right? Defined.
Yeah. Great, thank you, guys. I can see already another question. So what about ISER? Dima, I think you'd like to answer this one.
Yes, that basically is iSCSI with RDMA support, as far as I know. And I actually touched historical aspect when there were early days when you can compare, let's say, Ethernet without RDMA and fiber channel, then probably you would see that the performance and the ops numbers are much higher on fiber channels due to lower latency. And the possible solution to could be is using such protocols as ICER, since it uses RDMA extensions and eliminate this specific bottleneck with latency. So you will get almost the equal performance like you can have with the fiber channel if we are talking about the same bandwidth. So ICER is just a modern version of iSCSI. So basically iSCSI is for Ethernet and ICER is for RDMA over converged Ethernet.
Yeah, but still on the bottom is
that's
actually this Ethernet use. It's a kind of different layer, right? Isn't it? Or maybe I'm wrong. To be honest, I'm not expert in this. This is why I was not talking about this part of the webinar. I had all the questions. Right?
I can see another interesting question regarding what do you think about ARM support in the storage world? Will it improve? Are you planning to support ARM like P, probably Raspberry Pi, maybe anytime soon? Speaking about ARM support, I can add a few cents as well, because there are some smart NICs, especially I could provide as an example Bluefield and Bluefield 2, when you can have a separate Linux PC inside the network card, and it can handle, for example, codes of Reed Solomon to implement erasure coding. So erasure coding can be implemented and running not on top of the central CPU of the server, but on the ARM CPU inside the network interface card. So I think in this specific field, ARM looks very natural when you can plug Smart NIC and offload some storage-specific tasks to this ARM CPU. That's what I'm seeing right now. So that's definitely one of the cases for these Smart NICs.
I would like also to say a little bit more. So currently, of course, because Apple released the laptops and the laptops actually with the M1 CPU, much more people actually has been aware that something like ARM technology exists, right? It become popular, and it also proved to be extremely efficient. Especially for these use cases where the Apple computers are being used. So what I wanted to tell you, we are very lucky that we have access to some technologies thanks to our partners like DIAWAY, that we are, for instance, right now working on the full support for the SMR hard drives, which are the high capacity hard drives. And we also know that soon, next generation of the hard drives, I'm not saying it's going to be this year, but each producer of the hard drives is working on this RISC-V CPUs, which are going to be part of the storage systems. And it will be amazing to see what the industry is going to do in the future when we actually can have access to some of the operations inside of the CPUs, inside even on the hard drive, to even run computation on the hard drive inside itself. It's coming exciting times, and Apple, by introducing the awareness in the market, make that there's more buzz about this. Of course, Raspberry Pi was doing it before, but it was not as big impact, you know. And I need to also tell that the new Raspberry Pi version 4, which is currently available, is much better regarding the I/O support. So it actually starts making sense to build some kind of the, especially Internet of Things, storage, distributed storage solutions, scalable scale up solutions, scale out, I'm sorry, solutions.
Okay, thank you very much. Dima, I can see, yes, I can see actually one more question. I just cannot enter Q&A session again, Dima, and I can see there's a question. Did you answer it already or not yet?
Yes, we addressed it during the myth
Okay,
number
cool.
4 regarding economics.
Cool.
So that's basically it.
Okay, so
yeah.
we are exactly 15 minutes after original time because we answered the questions. If anybody has more questions, they can send email to us, right? Where is the email? On the here right now, webinars@diaway.com. Perfect.
Yes, so you can also find all contact information on our webpage, on our LinkedIn, Facebook, whatever you wish. So yeah, at this moment, I'd like to thank you for being with us today. It was a great pleasure. We really like to, as I'm always saying, we really like sharing our knowledge. That's basically our mission. So yeah, thank you guys very much, and we're looking forward to our next webinars. We already seen some comments from you about what we'd like to talk about, and yeah, we're really glad to have this opportunity. So thank you very much.
Can I ask a question? Can we send the marks? Can we send the marks to the people who asked the question? There was 2 or 3 people asking for, and let's ask the marks to them. Okay, let's ask.
Yeah, I think
guys need to send us the emails, the mail address, right?
Yeah, that's
yes,
pretty
please,
nice idea.
please send us. Please do.
Okay. Thank you. Thank you guys. And
thank
you very much.
Take care. Bye.
Bye bye.
Okay, bye bye.